Hello, welcome to this video which I'm going to have a go at a integration of parametric equations problem. This is a problem from the Pearson Edexcel textbook, so you probably see it from there. Now we've got the parametric equation x equals 1 minus t squared, y equals 2t minus t cubed, and t is an element of the real number set, so it's all the real numbers. We've got to find this area here. Now, so we've got this line here, which is the normal to the curve there. So that's going to affect the area. Creates a little triangle there, which we'll need to find later. What I'm going to do first, though, is do the integration bit. And I've got to first work out my limits for this. So you've got a limit there and a limit there. So let's work out what this limit is here in terms of t. So we look at point P. I'll call that just helpfully point Q. Now at point P, I know that x equals 0. So what I'm going to do is I'm going to put 0 into this. And if I put 0 equals 1 minus t squared equals 1. Well, that means t could be theoretically 1 or negative 1. Well, let's see which one it is. If I put that into y, I know that y equals 2t minus t cubed. So let's see t equals 1. Let's try. If t equals 1, then y will be 2 minus 1, which is 1. That looks okay. If t is negative 1, so I'd have negative 2, take away, and that would be negative 1. So you get negative 1. So I want that one. I want y to be 1. I don't want a negative y. So one limit. So the limit at p is going to be t equals positive 1. As I say, finding the limits is one of the tricky bits here. So that's why t equals 1. So we've got point Q. Now at point Q, we know that y is 0 because you're on the x-axis. It sits on. So y is 0. So I put 0 equals 2t minus t cubed. Or 0 equals t lots of 2 minus t squared. Well, you've got either t equals 0 or t equals root 2. Well, let's see which one works. If I put that into x, so x equals 1 minus t squared, which would imply that x equals, well, 0 squared, x would equal 1. For this one, well, root 2 squared is 2, 1 minus 2. I get x as a negative. Well, x is clearly not negative there, so I don't want that one. I want this one, and that is t equals 0. So the limit at q is t equals 0. Hope you followed that. If you're not sure, do rewind and have another look through. It's quite tricky dealing with the limits. So we've got the limits there. Now, let's do the next bit. Well, we're going to integrate. I've got my limits of 0 and 1. Now notice that the smaller number is up there because I'm going from 1, t is 1 to t is 0. I'm going to do y dx dt. So remember, that is our method. So let's have a look. So the x is 1 minus t squared. So if x is 1 minus t squared, I know there that dx dt is negative 2t. So I've got y times negative 2t. Y is 2t squared. So I've got 2t, minus t cubed. That is y. Dx dt is negative 2t dt. So there we go, just applying that. So there's my y, there's dx dt, and I've worked out the limits. It is quite a long question, this is a tricky one. So we've worked out our limits and we've got this. Well, let's work from there. What I'm going to do now is a nice little trick. 1, 0, I can, if I multiply by negative 1, I can actually change those. So what I get is that becomes 2t. Now I can expand that. 2t times 2t is 4t squared minus 2t to the 5. Sorry, yeah, 2t to the 4 dt. So I've just multiplied by negative 1. So imagine that's positive. That flips the limits. That's quite a nice kind of trick. And then you've got 4t minus 2t to the 4. Then what you've got here is the integral, which is 1 between 1 and 0. 4t cubed over 3 minus 2t to the 5 over 5. Well, let's calculate that. So you've got a big fat 0 there. When you put 0 into there, you've got 4 over 3 minus 2/5. You can do that in a calculator, but 20 over 15 minus 6 over 15 is 14 over 15. So what's that 14 over 15? The whole area, if I draw around there, is 14 over 15. But I need to get rid of that triangle there. How do I get rid of that triangle? Well, I'm going to get another bit of paper and I'm going to show you. That triangle we know is made by the x-axis, the y-axis and the normal. So let's look at this. We know point P is when, from there we know at point P, we know x equals 0 and I know y equals 1. I've already done that work before when I was finding the limits. So that's quite useful. I can also need to find the gradient. So dx dt, so x is 1 minus t squared, so that's going to be minus 2t. dy dt is going to be, let's have a look, 2 minus 3t squared. So so we need t here as well, sorry, we need t here. At point P, we realised t was 1, didn't we? Yeah, t is 1. So when t equals 1, dx dt is negative 2, and dy dt would be negative 1. 2 minus 3 lots of 1 squared. So we've got dy dx is that over that, which is a half. So we know that if I had a tangent there, that gradient would be a half. So the gradient of that normal is going to be negative 2. So the normal is going to be y equals negative 2 x plus 1. So let's look back. That line there is y equals negative 2x plus 1. And there is the working for that. I know that the y-intercept is 1, and I work out the gradient of the tangent, which is a half, using dx to t and dy dt divided by the x to t, and I get that. Well, if that's 2x plus 1, we know that's 1 there. That goes through there at 1. What's the coordinate there? Well, when y is 0, x has to be a half. So I've got my triangle there. Let's do a bigger drawing of that triangle. So they've got this triangle made by the normal, which goes through 1 and it goes through a half. And there's the origin. So it's going to be half times the base times the height. So it's a quarter. This is a quarter. So what is our total area of the region? Well, I've got the area which we found earlier, all of this, which was 14 over 15. Let's go back. We did that integration. We've done that integration to find 14 over 15. And then the area of that little triangle we're cutting out is just a quarter, minus a quarter. Okay, well, let's make it into 60s, shall we? 15 over 60, 28, 56. So 41 over 60 is the area. Lot going on there, quite a tricky question. Let's just recap. I first work out my limits, which are represented by that point and that point. You have to find t. You have to find t. So because x is 0 there, you can have t would be 1 or negative 1. Only t equals 1 makes sense. Y is 0 here, so t is either 0 or root 2, and only 0 works. So we've got our limits, and we've got y dx to t dt. That worked very nicely to give us 14 over 15. We then worked out the normal. That line there is the normal from P. And at P, we knew x was 0, y was 1, t was 1. And we got the equation of the normal, which allowed us to work out the area of the triangle. And then we took it away. There is a lot going on in that question. A hell of a lot going on. Hopefully you understand it now, and go back and ask any questions you wish. Thank you very much.